Hello and welcome to Unit 3 of Basic Electrical and Electronics Engineering. We learn what are VI characteristics, forward bias characteristics, cut-in threshold voltage, reverse bias condition, application, and its summary. The VI characteristics describe the relationship between voltage and current in a diode. This curve shows how the diode operates under forward bias and reverse bias conditions. Understanding this behavior is essential for analyzing and designing electronic circuits. When a diode is forward biased, positive to P and negative to N, it begins to conduct. Initially, only a small current flows until a certain minimum voltage is reached. Once this threshold voltage is crossed, the current increases rapidly. For silicon diodes, this threshold is about 0.7 volts, and for germanium diodes, it is about 0.3 volts. The cut-in voltage, also called the threshold voltage, is the minimum voltage required to overcome the barrier potential. Below this voltage, the current through the diode is almost negligible. Once the threshold is crossed, the current rises exponentially with voltage. In reverse bias, the positive terminal is connected to the N side and the negative terminal to the P side. Here, the diode blocks current flow. Only a very small leakage current is present. The diode acts like an open switch, and no significant current flows until breakdown occurs. When a very high reverse voltage is applied, the junction can break down. This is called the breakdown region, where a large reverse current suddenly flows. There are two types of breakdown: Zener breakdown, which happens at low voltage and is controlled; avalanche breakdown, which occurs at higher voltages and can be destructive. Zener diodes use this property for voltage regulation. The VI characteristics are very important in practical applications. They help in designing rectifiers and voltage regulators. They are used to select the correct diode for a particular circuit. They also help us understand the limitations of diodes and form the basis for devices like Zener diodes, LEDs, and photodiodes. Let us quickly recap. In forward bias, a diode starts conducting after its threshold voltage. In reverse bias, only a small leakage current flows until breakdown. The VI curve gives a complete picture of the diode's behavior. This knowledge forms the foundation for rectifiers, regulators, and other semiconductor devices. That brings us to the end of this session on the VI characteristics of a P-N junction diode. Thank you for watching and see you in the next session.